Alright, hi. Section 3, Dynamic Braking Control. Locomotive control, electric motive diesel, the GP35 static control. Alright, the dynamic braking control. The dynamic braking traction motor reconnected to separately excited generators. The wheels are connected to series across the main generator. The motor armatures are loaded with a fixed grid resistor. The torque is required for the driver armatures derived for the motion of the train along the rail. The armatures are connected with a series of the dynamic brake resistor grids. On the basic dynamic brake, the two armatures are connected with a series of the two grids. On extended range dynamic braking, the four armatures are connected with a series of four grids. GB35 uses 886 tenths of a loading resistance per motor. The load requires the motor field is excited with the fuel current. Alright, good ventilation is also required. The excitation system is capable of providing sufficient current to the engine and idle speed. The need for the ventilation requires the engine operator to run 5-speed dynamic braking. Dynamic braking control consists of two main categories: the manual control, which the locomotive operator has over the amount of the brake used; the automatic armature current limit to protect the armatures and grid from the overload. The operation of the two phases of the control is shown with the detail following the pages. The manual control is explained first. Alright, shown in the locomotive, the circuit connected with the dynamic braking selector handle still B. The position, the sequence of the going through the power brake as follows. The throttle is in the return to the idle selected position B position. The shield shot in the battery field drop out in the BR shield shunt terminal. The BR picking up the interpreted circuit with the series parallel power connectors dropping out of the circuit. The BK is completed with the BK picking up the interpreted circuit with the power brake contactors BK1 and BK2. The interlock for the BK2 closes the complete circuit with the BK, the series of the contactors, series 1323. Alright. Here's 13, series 13 transition, excitation motors 1 and 3 and 2 and 4 on series 24 and 23. Brake BKL. Once again, I don't know if I can teach this. The series contactor Cs 13 and 23 are closed. The generated residual current flow through the traction motor with the motor armature develops the flow of the dynamic brake grids to the residual current with the minimum connection generator shield front with the reserve across. The auxiliary generator current is limited to resistor circuit required for the block generator's residual. The brake rely on pickup with the disconnected load regulator arm number 3 side of the power load regulator coil. The 24T wire is now connected with the number 3 power load regulator. However, since the throttle switch has not been picked up upon no voltage applied with the 24T wire, the residual generator causes the signal of the T3 applied with the number 1 side of the power load regulator. The power load regulator contacts move 8 and 6. No energy is applied with the magnetic amplifier drivers. Alright, let's do this part right here. The auxiliary generator field motors contacts 7 and 8 through field motor series 1, 3, and 3 of the BIOS coils, the rheostat 1, and on the first circuit of the auxiliary generator. And then the second circuit you will find the load regulator on rheostat 2, rheostat. The auxiliary negative goes through the back BR relay, shield front, transition relay. On the farthest relay current, you find the brake control with a brake throttle switch and a brake selector switch on the outside of the negative term, largest circuit. To the trailing units, 24R and the 22 rectifier, the BRE gated relay to the power load regulator contacts 1 through 3, and power road regulator. You have rheostat 6, 7, and 3, and CR and terminal 3 transistor marked off with rectifiers. Also, on your driver coils, field manual on the third and coil from the auxiliary third parallel circuit from the auxiliary generator, field motor 1, 2, and 3, and line parallel on currents 11 through 3. The DBR and the power load regulator are also on this circuit. And that should do the bottom circuit. Alright, this one shows the alternator going through the back battery field, double gated field motors, rectifiers, and through field motors, one through, 1 to 3, which is on both negative power field, battery shield, shunt with reverser, rectifier, closing the deal between the alternator and in between the, field motor and switch. The main generator has different coils on the motor fields, winding 5, shield front reversers, shield front transistor, shield front transistor relay, field motors 1, 2, and 3, open contacts 9 and 10, relay. That also goes into the first relay of the auxiliary generator. Then in a broken relay, you see the battery field accelerator, reverser, backward field relay, resistor, rheostator, rectifier, diode, and series 24 and series 13 on the back level, and BKL series. Alright, figure 3-2 shows the throttle move with the idle position corresponding with the run 1 power of the T1-2, energy of the BFA and the SFA, shield front, field. Shunt field has been picked up. The shunt field picking up the drop of the ORS, causing the load regulator to move the maximum field position. Shunt field, no other function exemption with the BFA will slip the ride of dynamic brakes. This shows the control and the fuel pump switch with the brake throttle switch going through the BFA and the shield line with current. The BFA battery field, however, the picking up of the negative magnetic load winding of the D14 alternator would result in 1.5 amperes minimum battery field concern. Mention the conjunction of Figure 1.6 isolation section of the handbook since the basis coils are still excited with 135 to 160 amperes. Alright, I don't think the drain, this has changed. Let's just, Alright, the drawing does not change. Maybe it does. In the minimum brake position. But we went over it once, so I'll just keep that in mind. If I'll go over it whenever we talk, every page. 1 amp for the battery field contract bucking current of the shunt field. The current is sufficient to hold armature with minimum of 200 amperes of top speed. The load regulator is maximum field position, but the 24T wire is still at 0 potential. The power load regulator contact still is 8 and 6. The magnetic amplifier drive coils are not energized at this point. The 10 and 9 compensation coils are stability control compensating for the current with change of the generator field. Like I said, generator field 1 and 2. 1, 2. Main generator, you have your diode, your auxiliary generator. Talking about how the grids go off, 2 grids for 2 motors, 4 for 4. And not overloading the circuits. The operator has advanced the brake handle circuit sufficient with the cause of the 10 volt potential for the T24T train line, which is the train line units over here with the brake throttle and the switch, which we're on. The 10 volts ampere with the dynamic braking Zener does not conduct the 24.5 volts supplied with the current flow with the Zener resistor, resulting in the voltage of the number 3 terminal of the power load regulator coil with a value of less than 10 volts. The function of the Zener diode provides a software application, dynamic brakes, and brake throttle handle to move slightly. This allows the train under the conditions of train weight and track grade to maintain the desired high track speed within the dynamic braking. Alright, so there's your diode in between the 24T wire. Well, the signal of the 24T wire is higher than feedback applied with the number 1 terminal. Number 1 terminal over here by the power load regulator. Applied with the number 1 terminal power load regulator contacts and the 8 and 2 for the contacts. So, also through this power regulator, you have your 8 and 9 contact relays going through in the brake or BR. That might be a diode. Traction motor field current increase the field back, increases the high voltage high enough to the AT contact power load regulator. Open the 2 contacts oscillate between open and closed, regulating motor field with strength. Alright, so the regulator field motors 1, 2, and 3 in shunt, and also are getting regulated. See the accelerator, the regulators, the reluctors regulating field motors 1, 2, and 3. The original less voltage across the number 4 grid resists the dynamic braking relay operating valve. The dynamic braking relay not operating set with the regulated with 700 amperes through the grids. The dynamic brake relay contains 8 closed and 8 to 2 closed. Reaction taking place in the shunt field circuits will be dealt with later. After making sure all the train slack is bunched, operators should condition figure 3/4, move the control handle slowly, maximum brake position. This results in 50 volts applied with the number 3 terminal brake load relay coil. The battery field of the current increases the potential proportional until the motor field excitation reaches the level of the resulting 700 amperes current. So we're over here on the brake load regulator 8 and 3. 8 and 3 field motor regulator first to the auxiliary generator. To the right of the first parallel connection on the auxiliary regulator. From the power regulator, coil. Alright, 700 amperes current result with the voltage of 310 plus or minus 5 across the one of the resistors in number 4 grid, which this voltage drop the dynamic braking relay circuit. The RH10 is properly adjusted with 50 volts applied with the zero arrow diode. Trying to find rheostat 10. Rheostat 10 is here on the series, which shows the dynamic braking relay switch and the rectifier and diodes. Alright, the ZA1 constructed with the maintained 50 volt drop across the diode. This was begin with the conducting 50 volts with applied. The Z1 conducts current flow through the dynamic braking regulation. The dynamic brake regulating coil from 4 to 5 at about 100 milliamperes. The dynamic braking regulator contacts 8 and 2 open and energized to remove the magnetic amplifier driver coils, battery field excitation, decays, and braking current drops. When the braking current drops below 700 amperes, less than 50 volts is applied with the Z1 blocks, Z1 and Z1 blocks. Dynamic braking regulator contacts 8 and 2, which is over here. Power regulator dynamic brake rigging 8 and 2. And your Z1 diodes on this circuit for the before it goes into the to the series 1324 of your traction motors, which are called the grids. Just like the series 24, series 13, and the dynamic braking rigging circuit as a grid. The condenser of the dynamic braking regulator capacitor circuit provides anticipation smoother voltage peak, resulting smoother operating regulator. This shows the braking regulator braking system motor for series the brake rigging the relay and the brake warning relay will pick up the braking current relay exhausting 350 volts plus or minus across the number 2 terminals and 3 of the braking resistor grid. The brake wheel relay picks up the circuit of the brake field, battery field accelerator, interpreted the battery field accelerator contact drop that removes the excitation main generated battery field, causing a reduction in brake current. The E and F contacts the brake field accelerator, battery field accelerator, close the insert of the RE61A of the brake wheel relay. This recalibrates the back wheel relay to 290 volts plus or minus 10 volts. The voltage across the number 2 and then the 3 terminals of the grid. Number 4 brake current with less than 700 amperes. The brake field and the energies picks up the energized battery field and simple modulation battery field current for the reaction taking place and shown explained in the following text. Hey, here's your brake wheel relay on the line from the auxiliary generator, which is like switches off and on to protect the overloading of the excitation motors during speeding and acceleration and deceleration. Modulation of the battery field current occurs normally under the four conditions: power load regulator, dynamic braking relay, power brake wheel relay, wheel slipping action. Each of these conditions cause the change excitation main generator battery field. Assuming the power regulator, dynamic braking, and the brake field accelerator contact that having open to decrease the battery field excitation. Good portion of the D14 alternator zero voltage is impressed upon the battery field. The current begins with the flow of the battery field. Back voltage built up in the battery field, the transformer action shunt field as well. The belt polarity introduced the voltage and is shown in figure 3.6. The arrowheads are in circuit involved. As you can see, the voltage included with the shunt field curve, the current of the field third reactor winding 10 and 9 with the current opposed with the current 11, 12 drive closed, increase the impedance of reactor. This course limits the flow of the current battery field that stabilizes the system response rapid to the battery field current. Compensating effect weaker with the driver signal net result of the building up of the current battery. The buildup of the current battery field through the motor field of the motor armature slow with the reactor compensating the winding. Figure 3.7, the assuming that either the polar regulator, the dynamic braking relay, or the battery field accelerator contacts have been open and decrease the battery field excitation current. The compensation effect shown in Figure 3 takes place by additional action that occurs to ensure stable regulation of the dynamic braking current is 700 amperes. A normal armature central rise with the voltage drop across number 2 and number 3 terminals. Grid number 4 as all rise. The rising voltage of the capacitor connected with the parallel RE69 and G1 the change of current together with the resistor current, the result of the premature highly dynamic braking coil or relay current the dynamic braking relay pickup of the system overshot with the interrupting current with the magnetic amplified driver coils limiting barrier field. As the capacitor has become charged with the charging current, no longer the dynamic braking relay coil with the coil current within dependent upon the zero current, the operating point of the dynamic braking relay rises to 700 amperes. The capacity becomes charged with the 700 amperes. The Z1 contact with the dynamic braking relay will pick up the current with the RE69 and RH10. The anticipation effect together with the compensation result of the dynamic braking function with little no overshot. This effect is taking place of the normal operation during the wheel slip recovery and its accidental mishandling of the operator. The anticipation effect. Alright, over here you see wheel slip number 24 and 13 for the series round and you have your zero diodes going to the dynamic wheel braking relay. Brake wheel relay and dynamic braking relay. This is your trucks right here, the traction motors. This goes into the switches. As you can see, this is on the auxiliary generator side of the thing. So you see field motor 1, 2, and 3. Field motor driver coils 1, 2, and 3. Short field shield front terminal transducers gutted in before the main generator. Closed gates. During the dynamic braking, the CD coil, the wheel slip relay, the wheel slip RWS. Connected across the traction motor field, but the motor fields have been because even the motor field current with the main generator voltage high enough to bring it back and pick up the wheel slip, and the wheel slip generated the excitation, reducing the back barrier field exhaustion. BFA, right here. Alright, section 4, troubleshooting.